Hello and welcome to a new video. This is for the Zeta Math UC book, and we are on lesson 23, which talks about how to transform any fraction to a decimal and a percent. So lessons ago, I don't even know what lesson it was, at some point Math UC asked us to basically convert, I guess it was around whenever we started talking about percents, to convert between fractions, decimals, and percents, and basically had kind of a short list of ones to have memorized. So for instance, a half, it's a really easy fraction to memorize as, or a good one to memorize. Maybe it's not easy, but a good one to memorize is that 1/2 is 0.5 and is 50%. 1/4 is a quarter, literally, and also never mind. A fourth is a quarter, which would be 0.25 if you're thinking about quarters, right, or 25 cents, and then would be 25%. So those two for sure would be good ones to have memorized. But basically, there are infinitely many fractions, so we can't just sit around and memorize every single fraction. It'd be nice if we had a way to convert between them. And the way to do that is to divide. And the thing that we want to at some point come to grips with, if not already have come to grips with it, is a fraction is just a way of writing division. So when you see a fraction like 1/3 here on this first one, the other way to think of it is that we have 1 divided by 3. So in order for us to take 1/3 and figure out what it is as a fraction and a percent, we're going to do some long division. We're going to divide 3 into 1. And what's great is that we've just spent like 5 billion lessons in Math UC figuring out how to divide things where we end up with decimal answers or there's decimal somewhere involved. So we are going to add zeros on here. We're not going to divide forever. Basically, there's two options of what's going to happen here. Either it's going to divide evenly, or it's going to be a decimal that repeats. Those are our only two options if we're dividing whole numbers. So 1's a whole number, 3's a whole number. We're dividing them. It's either going to repeat or divide evenly. So if it divides evenly, hopefully it happens pretty quickly. If it doesn't, hopefully we see the pattern pretty quickly. But I don't think we should stress out too much about finding that pattern. I think that we probably should just go to about 3 decimal places. Because if the whole reason we're doing this is to eventually find a percent, percents have to do with parts out of 100. So if we end up with a decimal like 0.55, to change that to a percent, we just move the decimal over 2 places to the right, and it ends up being 55%. Which means, really, after we've gotten to like 3 decimal places, it's not going to be something we normally think about with percents. So a lot of division, basically, is going to happen in this lesson. So let's see how good we are at division. I'm going to say 3 goes into 1. No, it doesn't go into 1. I'm going to put my decimal up here, and then but I kind of ignore it inside the problem itself, because now I'm saying, does 3 go into 1, 0, which is also known as 10? Does 3 go into 10? Yes, it does. It goes in 3 times. And then we do 3 times 3, which is 9. So we're doing 10 minus 9, which is 1. We're going to drop down our 0 and then start over. 3 goes into 10 3 times. I'm suspicious. 3 times 3 is 9. 1. So when we talked about repeating decimals, back a few lessons ago, it's this idea of like, okay, the same thing is happening over and over again, and no matter how many zeros I add, this is just still going to keep being 0.3. So we call this 0.3 repeating. We can say that 1/3 is equal to 0.3 with a line over it, and anybody who's taken at least as much math as you will look at that and say, oh, I see what you mean. You mean that 3 goes on forever. Another way to write it, though, is if we're rounding, we could use an equal sign that's like wavy or squiggly. That equal sign means that we're giving an approximate answer or an estimate or roughly. Usually it just means that we've rounded. And so, for instance, if we have 0.3333333, we could think of it as 0.33 or 0.333. Now, part of the issue with this is that once we start thinking about the percent, we need to be able to move the decimal over 2 places. So it'd be really nice for us to actually look at this one right here and say, what happens when I move this decimal over 2 places? Well, then I get 33%. But what do I do with this 3 at the end? Well, in that case, we could either write 33.3%. That's an option, and I kind of like that option. But we also can write it as a fraction at the end, not point. I don't want the point there. We could write 33.3 as 33.33%. And the reason we can do that is because remember that with our decimal division, that we can at some point stop and say, okay, I have 1 left over. So I put the 1 that's left over, the remainder of 1 over what I'm dividing by, which is 3. And that's how I get the 1/3. Now, the reason I think this is important to think about at least a little bit is because if we just take 33.3%, or even if you had said it was just 33%, if we're saying that 1/3 is equal to 33%, we've actually kind of got an issue here. Because if 1/3 equals 33%, then each of these 1/3s should be 33%. And if I add 33% together 3 times, that only adds up to be 99%. So that's why writing this fraction is helpful. 33 1/3% is the most precise percent that we can write here. Or if I could have put a repeating symbol over this, and that would make that better. But if we imply to somebody that it's just 33.3 and that it doesn't keep going, we've kind of left off a little bit of our percent of a whole there. And this is one of the reasons why I don't know. I don't think we often see sales that end up using thirds or 2/3 or things like that, because you're just never going to have anything that divides evenly. So B, 2/5. Now, I want to point out something, which is that decimal numbers have to do with powers of 10. So 2/5 is something that we could actually make have a 10 on bottom, and that would be one way for us to figure out what this decimal is. We can absolutely do this the same way as what we did on A, where we divide it. But I just want to throw out there that if you can change the bottom number into a power of 10, so like by timesing 2, we just have to do it to the top and bottom so that we end up with an equivalent fraction. And that's helpful because 4/10 as a decimal is 4/10, right? So if you have something where the denominator goes into 100, then it can be quicker to do it this way if you realize that's a thing that's happening. So 0.4 as a decimal, we move the decimal over 2 places, which means we'll have to actually add a 0 and get 40%. So if you do 2 divided by 5, you should get 0.4 as well. So just keep that in mind. We just have a total of 6 examples here. And so we're just going to be doing a bunch of division. Remember that, or at least I think I talked about when we were doing decimal remainders, dividing by 3 repeats, but repeats nicely, right? Because it's 0.3 repeating or 0.6 repeating. Dividing by 7 is something that repeats but takes a while to repeat. So I'm just going to find 3 decimal places and then use that. That's my personal preference of how to do it. And I give you permission to choose to do that as long as everybody else in your life is okay with that. Dividing by 9 is one that repeats, but repeats fairly nicely. So if you are doing a bunch of these, you might notice kind of a pattern of like which problems are easier and which ones are not as easy. So let's do this division. 7 goes into 3 0 times. And so I'm going to put my decimal up here and say 7 goes into 30 4 times, which is 28. And I'm going to drop down my next 0. 7 goes into 20 twice. So I'd minus 14 and get 6. Drop this down and get 60. 7 goes into 60 8 times. So then minus 56 and get 4. And so I guess we could actually write this as 4/7 then here at the end, or I've actually gone, I guess, farther than I need to, because if I want to be able to write the percent as 42 and some fraction, I actually need to go back to, where would this be? 2 minus 14, where I got 6 as a remainder. Because the 6 as a remainder means that this is 0.42 and 6/7. So as a percent, that's 42 and 6/7%. Now, I honestly am about as happy with that as I am with writing 42.8%. So just wanted to throw out there, though, like how one might go through and figure that out. Well, let's look at D, 4/9. I like 9, or dividing by 9. I mean, kind of. Like, it's both nifty and kind of weird. I don't know. 9 goes into 4. No, just kidding, it doesn't. 9 goes into 44 times. So we subtract. And 9 goes into 40. Wait, didn't we just answer that question? Yes, we did. Minus 36. 4. Okay, so we're just going to keep ending up getting the same thing. So our options here for writing this as a decimal is we can write 0.4 repeating. We could write 0.44 and say that, we've rounded. When we could actually also do 0.44 and 4/9. I don't like writing decimals and fractions together, but that's helpful for when we write this as a percent. We move the decimal place over 2 places, so 44 and 4/9% would be how we could write that with, maximum information. Or you could put 44.4, put the line over that last 4 to show that 4 is repeating. I like dividing by 9 like this because, like, 1/9 is 0.1 repeating, 2/9 is 0.2 repeating, 3/9 is the same as a third, which is 0.3 repeating. That pattern continues all the way up to 8/9. Maybe make 8/9 into 80 would be, because 9/9 is 1, so 9 goes into 8. Why can't I? Oh, yeah, that is 8, because that's 72. And then it's 8, 8, 8, 8, 8, 8, 8. Okay, sorry. Let's look at 7. I like dividing by 8 personally. I think it's a fun time because it divides evenly within usually 3 decimal places and sometimes fewer. So 8 goes, actually, does 8 go into 100 evenly? No. I was going to say maybe we could use that trick, but I don't think this is going to go, this doesn't go into 100 evenly. So we can't just say 7/8 times something and get over 100. But I tried. Let's see. 8 does not go into 7, but 8 goes into 78 times. And then we get 6 and we drop down 0. 8 goes into 67 times. And then drop down 0. 8 goes into 45 times. So 0.875. And then that's it, because that goes in evenly. And that's our decimal. So then we move the decimal place over 2 places, and our percent is 87.5%. F1 divided by 15. I'm gonna be honest, this doesn't necessarily look super fun, but we'll see it through. I don't know why I made the symbol so long. We'll just roll with it. Now this time we've got 15 doesn't go into 1. It doesn't go into 10 either, so we do need a 0 placeholder. 15 goes into 100. This is why this does not seem pleasant. How many times does 15 go into 100? I want to say 6 times. So then we minus 90 and get 10. Wait. Now we have 100 again. 15 goes into 100 6 times, and then that's going to continue on, right? So this is 0.06 repeating, which as a percent, we'd move the decimal over twice and say that it's 6.6 repeating percent. Or we could say it some other way, but I like that way best personally. So just whenever it's 0.06 like this, you move it over twice, so it ends up being 6 and not 60. Make sure that that makes sense to you. And that is how we can take any fraction and transform it into a decimal or percent. Now, almost all of these we did end up doing long division on, but certainly check to see if they give you something easy like a half or a fourth, then that's things that you could probably just know off the top of your head. Or tenths, that's a good one, like 2/10. Why would they give you 2/10? 3/10, for instance, is 0.3, and then you can change it to a percent. So please, if you have not already, subscribe to my channel so that you'll get to know anytime I put out a new video, and like the video, and have a great day. Thanks.